since we've all chatted. Excited to do another one of these presentations for everybody. Hopefully see a lot of you later this year at CF Summit in person. So looking forward to all of that. So today, a funny named session title of You Handle the CRUD, Let Them Handle the Rest. Basically, what we're going to be talking about is you have a database that you need a database, you want to put it somewhere. It's got to be hosted somewhere by something. So we're going to talk about a lot of the different options and ways that you can do that, from self-hosted to cloud-hosted and different variants in between, and some really things to look at and consider when you're trying to figure out, where do I put my database? So a little bit about myself. I started building web applications a very, very long time ago. I am on the content board for Learn CF in a Week. And I like taking long walks on the beach and kicking people in the head, but not at the same time. It's a little more complicated. I get in trouble that way. But I am actually a third-degree black belt in Taekwondo. It's one of my fun little hobbies outside of everything else. Just recently got back from our World Championships where I competed for a world title in Taekwondo. I didn't get it, but hey, at least I tried. But off to next season and see what happens then. But yeah, I'm a multiple state and district champion in Taekwondo. It's a fun little hobby. My son is actually a third degree as well, and he's actually an instructor at our studio. So it's a lot of fun there. So let's learn something. So we're going to talk about some stuff. We're going to go over some things and the differences between them. Trying to help you decide what might be better. And then we'll have a little Q&A and hopefully answer any questions that you may have as best I can. So, database hosting. You got a database, you need to put it somewhere. But where is that somewhere? You got really a couple little options. You can either cloud host it or self-manage it yourself. But those can actually be the same. So we're going to kind of normalize some verbiage for the rest of this presentation so we can talk and understand the same. So by cloud, I basically mean using somebody else's database infrastructure. They have a pre-built database infrastructure. You just put your database in it. So for example, like MongoDB, Atlas, or Microsoft Azure are a couple examples of what I would call for this presentation, the cloud. They already have pre-built systems where you just put your database in them. Self-hosted, by that I mean you're managing the server yourself and what it runs on and so on and so forth. Doesn't matter where it's hosted. So you could have a cloud VPS hosting your database. For this presentation's thing, I would still consider that self-hosted. Although you're not actually hosting the machine itself, you're managing the machine and all of that. So we'll consider that self-hosted for the sake of this presentation. So where do we start? So you've got a database. Where do we start in figuring out what we want to do? Well, in order to figure out what you need and where you want to put it, you need to figure out some requirements based around your database. And then you got to take those requirements and see where they fit. There are scenarios where you have to do the inverse, where you're being forced to use a specific thing. Let's say Microsoft Azure. That could be due to corporate constraints or other constraints that are out there. But let's just say that you don't have constraints and you actually can look at your database requirements and then figure out where you want to put it. So the number one thing to start with is how much money you got. What's your budget for what you're going to do? You will either fall into one of two groups. You will either have no budget and you want everything you can do for free, or you got lots of money. There's really no in between here. It's going to be one or the other. 100%. There's really there's no I got a little bit of money or I have some, because a little bit of money becomes a lot of money very quickly. So you either in the realm of no money or lots of money. Do keep in mind throughout this presentation, I am not going to give you any dollar figures on something, because those fluctuate very rapidly and are very specific to what you're doing. So for me to give you numbers wouldn't be the best course of action. So I'm going to just give you some ideas on where you can put it, and then you can go through all that and figure out the cost all on your own. I will give you some ideas of how some are more expensive versus others. So that's that. Oh, one thing, if you do have questions I forgot throughout the presentation, please ask them. I will reach out as best I can and answer any questions. Also, make sure you stay to the end of the presentation if you want to win a gift card. Don't leave early. You leave early, you can't win anything. So your budget is going... Friends don't let friends go to GoDaddy. This is so true. Sorry. Your budget will drive most of the decisions. It is 100%. Well, however much money you have is going to drive a lot of decisions you make as to where you go, what you do, and where you actually put the database that you need to have hosted somewhere. It's like the most number one biggest driving factor in what you're going to do beyond what type of database it is. So just remember, if you're using free, free is not necessarily free. There's a lot, you can get free database hosting, but free comes with a price, oddly enough. There's a lot that comes with free. A lot of free solutions start out free, don't end free. They have some form of cost to them. So they may hold your database for free, but if you want it backed up, it's going to cost you money. You want some of this, it's going to cost you money. If you go over this threshold of usage, it's going to cost you money. So free can very quickly turn into not free at all in a very short period of time when it comes to databases and database hosting. So, but also remember, you don't need something giant to hold something small. As I always say, you don't need a 4-car garage to store your motorcycle. That means that if you have this really small database holding only a few things, you don't need to go out and get a multi-tiered cluster with all this failover, yada, yada, yada. You probably wouldn't need any of that for something really tiny. So don't blow your pocketbook getting a 4-car garage to store your little motorcycle. So what could you potentially get for free? You know, lots of things. There are tons of providers out there that will be more than happy to give you free hosting. However, be very careful because free trial and free hosting are not the same. A lot of the free providers out there actually give you free trials instead of free hosting, and then shortly after your free trial ends, you're stuck and you have nowhere to go. So be careful with free trial. Most free hosting options, you have very limited size of how much data you can hold, as well as extremely limited feature set. So be careful with that as well. However, if you're just playing around and doing some stuff like some dev work and you just want to play some stuff, there are these little free options that you can have a database for a month. It's really good for some playing around with some stuff. Good for a lot of that. But if you're going to use a free hosting solution, make sure you have a plan to migrate off of that. In the event that your app now needs more than your free can offer. So make sure you've got a way to get away from that. Make sure that whoever you're hosting it with has a way to say, okay, you are going beyond the threshold of free. So here's a way to migrate out of that free realm. A lot of ways they're done is with paid add-ons. So you can have a free hosting and then pay to add more to it beyond the free. And that's where free no longer becomes free. So there's lots of different ways to expand your free. So remember, you get what you pay for. So don't expect to host your enterprise class database in a free solution. You will be sadly mistaken that it will work poorly. There are a lot of issues with free. So be very careful. Yeah, it's one thing that like Greg said, quality of service, some connections, stuff like that. Yep. You get a lot of, you get lower tiered service for free in a lot of places. So be careful. Like I said, you get what you pay for. Well, what if free is not for you? You don't want to even start out in the free realm? Well, get out your checkbook, because you're going to need some money. So let's gather some more specs before we keep going down this road of where do I need stuff. What type of database do you need? That's probably your next thing. So, okay, I got some money or I don't. What kind of database am I actually going to host or do I need for my application? Is it relational? Because you have some options. There's a few relational databases out there that you can use. Is it a NoSQL database? There are lots of them as well. So you've decided, so you got to figure out what type of database you actually are going to use for your application. You can use both. You can use a combination of multiple different types of databases. One nice thing with Cold Fusion is you can actually point multiple data sources to different databases as long as you got the drivers for them. And if you're using NoSQL, there's actually direct connect for example, Mongo right inside CF now. So a lot more options available nowadays. But let's just narrow that focus down a little bit. Instead of a few hundred databases, let's just deal with some of the bigger ones, like MySQL, Microsoft SQL Server, Oracle, Postgre, and then for NoSQL, Mongo, Dynamo, Cosmo, and Firestore. Raise your hand if you've actually used Firestore. My hand is down. Some other requirements that you're going to need to worry about. Database size. How big is your database? Not how big is it today. How big will it be in 3 months, 6 months, a year, 2 years? That's what you have to consider. Not how big my database is to start with, how big it's going to be. Because when you start paying for hosting, you're paying for how much storage space you need. Because not only do you need storage space for the database itself, you need storage space for log files, transactional stuff, as well as backups. So you're going to need space for all of that. So it's important to make sure that all of that is part of it. A lot of times, yeah, like Jim says, some of those services will give you backups for free, but they're going to charge you to restore. So careful. How can you determine your size? That's a very slippery slope question. So Greg asked, how can you determine the size of your database? It's hard. You have to look at what kind of data you're storing and then do some predictions on, okay, one user doing the normal course of action in my app generates this much data. What if I had 100 users doing that, 1,000 users, 10,000 users, and just kind of ramp that up to what that data might look like, and then kind of figure out where that will get you. So bandwidth and connectivity is another thing too, which we'll go over a little bit more a little later, part of that. But you have to see how much bandwidth do I have? How much am I paying for? A lot of providers out there, when you pay for hosting for a database, you're going to be paying for how much bandwidth you get per month. Databases can easily overwhelm that. So it's very careful to make sure you get enough bandwidth to make sure you have good data connectivity back and forth between your database and your app, and you don't run out. Security is also another big thing for your data. You don't want people stealing your data, getting inside your database. So make sure that whoever you're hosting it with has good security tools to secure your data, because you don't want your data becoming somebody else's without you knowing. So the other thing is, don't forget the SLA. For us, for SLA, service level agreement. It's very, very important that you have a very proper SLA for whoever's hosting it. It's one of the, in my opinion, it's one of the key components that is a lot of times forgotten when it comes to hosting. It's just ignored. Just like, oh, I'll get whatever. You can actually negotiate SLAs pretty easily, and get better ones if you're willing to pay for it. The better your SLA, the more you're going to pay. But most SLAs are actually given out with a 99.9% uptime rate, which sounds great. But when you do the math on it, that actually allows your system to be down 44 minutes a month. That's a lot. I'm sure nobody wants their system being down for almost an hour, at least once a month, and still being able to go inside the SLA. What you're looking for is actually the 5 nines, what's called the 5 nines, or 99.999%. Because if you're there, they can only actually have 26 seconds of downtime in a month. Anything more than that, they've broken SLAs. So it's very important that your SLA matches what your system can support. Sorry, Greg. So now that you know what kind of database you want, you have some information about it, where you want to locate it. You got to figure out where to put it physically. The cloud is really not this nebulous thing that exists everywhere. The cloud actually exists in regions and locations and physical footprint somewhere. So you want to make sure that where you're putting your database and its physical footprint is close to where your physical application resides. You want that to be as close as possible. You don't want to put your application in the West Coast, and it'll say California, and your database in West Virginia. You'll have some pretty big latency problems with that. So make sure you try and keep them close. But yeah, it's important to make sure that things are close, so you don't have any issues there. Because location equals latency. The farther away, the more problems you have. Don't get me started on Cloudflare, John. I'll get to that in a second. So latency is kryptonite for database transactions. A little bit of latency can kill a database transaction. Latency is really, really bad. So if you're dealing with a database has, let's say, a 200 ping from your app to your database, that's an extra 200 milliseconds of time to do something. And you're trying to do things as quick as possible. You want that sub way, way shorter. So you want to make sure that your connection is really, really good. So as I always say, keep your data close, your backups far away. I actually worked on a system where we actually had databases located in California and Florida, but the backups were actually located in Las Vegas and New York. They're for specific reasons. We had actually mandates where on the system where we had to have the backups geographically located to a different natural disaster area. So that, let's say, a hurricane wiped out Florida, the backups were safe in Las Vegas. And if a earthquake took out California, the backups were safe across the fault line in Vegas or even farther away in New York, so that one natural disaster couldn't wipe out the system and its backups. So it's always good to make sure your backups are as far away as possible, but still near enough that you can use them reliably. So let's take a reset for a second. So let's look at our needs so far. So figure out database type, location, potentially how big it's going to be over time, some connectivity issues. We figured out some backup stuff, some SLAs. So we kind of got a good idea of what we want to do and where we're going. So the next thing you need to figure out is scaling. Do I need this database to scale? Am I going to be good with one database for a long period of time and scale it later? Do I never need to scale it? What am I going to do? So when we talk about scaling, there's two different ways to scale a database. One is that most people are very familiar with, is called vertical scaling, which is just giving more power to the hardware you're using. For example, putting more RAM, more processor power inside the current database server to make it do more. That is a very common way to do scaling. It's called vertical scaling. However, the other alternate option is horizontal scaling, where instead of creating a very large, beefy server, you're creating smaller servers, but more of them. So now you can spread traffic across multiple servers that are of lower quality, but as a group can handle the power better. Now, scaling comes with a cost in different ways, where vertical scaling starts out cheap. Adding more RAM to a server is really not that expensive. But eventually you get to the point where adding RAM becomes very expensive because either A, your server can't actually take more RAM, or you've run the max on what you can do. So you need to get another server and replace the one you have with a server that can take more RAM or more processors, things like that, or more storage, where your current system just can't handle the scale anymore. So you need to go to something else that's bigger that can then scale vertically some more. Where horizontal scaling is a little different. Its initial cost is more expensive because you need to set up a second server, as an example, but then going forward, it becomes cheaper down the road. But scaling in a general sense gets very expensive. And that's where a lot of cost comes in when you're dealing with making sure that you don't have issues with your system. So beyond scaling, then you have to deal with fault tolerance and disaster recovery. Most don't worry about the second part of that, the disaster recovery. A lot of people don't even deal with the fault tolerance part. And disaster being spelled wrong is me not knowing how to type. So I could just say it was a joke. But yeah, I am very, very bad at spelling. It's my kryptonite. Funny. So make sure your disaster recovery plans that you're good. I appreciate you trying to give me the out, Greg. Thank you. But no, I'm an awful speller. Anybody that knows me knows this. Disaster recovery plan. Make sure you've got one. So there's two parts to a disaster recovery plan. One is the RTO, or recovery time objective, and then which is basically how fast do I need to get this system back up to a point where it can do what it was doing before it went down. Can I be down for 5 minutes, 5 hours, 5 seconds? How quick does this have to get back? That's what you need to. That's what you need to go into first when you're creating a disaster recovery plan of I need to get the system back up. Is how quick do I need to get back up? And then the other part of that is the RPO, or your recovery point objective. So if your system went down, how much data can I lose? Can I afford to lose an hour of data, 5 minutes of data, 5 days of data? How much data can I get away with losing? Because that needs to be how your big objective is. What data do I need to get back up? How far do I have to, if my database went kaput, do I need to just go back to the last full backup and I'm good? Or do I need to go to the last full and then incrementals and then reapply the logs, so on and so forth? So how much data, what is my objective? Where's my recovery point? It's important to know that when you make your disaster recovery plan and all of that, so you know what you need to get back. There's a lot more that goes into creating disaster recovery plans and stuff like that. But these are the main starting points to figure out, beyond who's responsible for what, who needs to do what, who's on call, so on. There's a whole lot of it. But keep these two things are super critical when you're deciding what to do. So let's say you're going down the self-hosted route for all of this, and you decided, I'm not going to use some pre-existing cloud. I'm going to self-host my stuff. So in order to do that, get a VPS from a provider, build up your own server, and then do all the things to get the database running. And I caution you, if you don't know what these are, this is probably not the right option for you, because this is not easy. This is very complicated, very hard. That's why there are systems like Azure, AWS, Mongo Atlas. That's why these systems exist, because doing this is hard. Setting up your own systems are very hard. It's much, much easier, and in the long run, generally cheaper to just do it yourself, do it through some provider. But I mean, it is what you have available. If you have people on staff to do this, then great, do what you can do. But I've done other presentations where being a DBA is hard. There's a lot to know, a lot to do. So there's no one solid answer. But if you really don't know the steps, like I said, to build up your own system, don't. Let somebody else do it. I mean, you could just hire somebody to do it for you. Wink, wink. Nudge, nudge. I'm kidding. So, to the cloud we go. So, if you're going to the cloud, there's lots of options. Your options are vast, but they're also limited. There's lots of things out there. No, I don't offer hosting. There are lots of options out there, but with each option comes limited selections. So be careful. So all those requirements we went through to begin with will very, very easily help you decide on who your provider is going to be and who you want your provider to be. So you take those requirements and then start matching them up to providers. And that's kind of why you do them first and see who's the better fit for what you're doing. So there are lots of providers out there. There are thousands of them actually. Do a search. There are tons of providers out there that will be happy to do what you're doing for you. Oddly enough, some of the providers out there actually use these guys. They just have their own UIs to these guys. So buyer beware. Some of them actually under the hood use AWS to store data, or Azure, or Google Cloud in some way. So be careful. You may just want to go straight to the source instead of using a third party. Some third parties have their own infrastructure. That's great. Sometimes those are cheaper, sometimes not. It all depends. But for the sake of this, we're just going to focus on the big three. Not that I'm endorsing any of them. It's just there's a lot more information on them and what they can do versus a lot of the others. So it's definitely easier to make a presentation for that than trying to dig into a lot of stuff. So, for example, so we have AWS or Amazon Web Services, Azure, and then the Google Cloud Platform or GCP. So if you're doing AWS, they got it all. They'll basically host anything for the most part. Azure will not host Oracle. They'll host pretty much anything else. Google Cloud will host SQL Server and NoSQL. That's about it. They don't host MySQL and some others. But although they all host NoSQL databases, they all have their own very, very specific versions that they host. So depending on what NoSQL version you're using or engine you're using, your hosting would be limited. For example, Google only hosts their own Firestorm or whatever it was. I can't remember offhand. They host their own and some other flavors of their own. So be careful with that. If you're using Oracle and you've got the coin to spend on using an Oracle database, go use OCI. Don't go anywhere else. Save yourself the struggle, the stress. Use OCI. And it's probably your number one best bet for Oracle cloud hosting. If you're using Mongo and you want to cloud host it, use Atlas. It's probably your best bet there too. There are lots of other options out there, but for these two specifically, these are probably your best bets for their hosting. So comparing the big three against each other, Amazon, AWS, probably has the largest implementation, US based and globally. Azure is a close second. They're getting bigger. Google Cloud doesn't have as much. They're newer to the game. Yeah, don't use Oracle. Yeah, I wouldn't suggest using Oracle unless you have to. Yeah, Oracle's fun. Fun to make yourself bang your head against the desk. Google's new to the game. They've got a lot less, but they have something interesting, which we'll get to later, that makes Google really, really nice for something, which we'll go to in a minute. So the cost comparison. So Azure is actually the cheapest, but they're also feature lacking, which we'll get to. AWS is the middle of the road for cost, but they have the most amount of stuff you could do. Google Cloud is actually the most expensive for a reason, which we'll get to in a minute, but they will cost you the most amount of coin that you can have to do something. So let's look at some pros and cons. So for AWS, it has, like I said, the most amount available. It's been around the longest, and it's arguably the gold standard for cloud reliability and security. It has more compute capacity versus Azure and Google, and all server software vendors make their programs available on AWS. So there's a lot out there. Some cons for AWS: you have to purchase support, which is a requirement. And because they do so much, sometimes when you start going in to use AWS, it is a little overwhelming. It gets really confusing, really hard to sometimes figure out what you need, because there is so much there. A little, yeah, more than a lot overwhelming. There's a lot there. So bite off a little bit at a time. There's a lot in AWS. For Azure, its benefit is how it interacts with all of the Microsoft stuff, which is its big selling point. If you're using Microsoft services for stuff, it's really almost the best bet. If you're using Teams and other aspects, Outlook, so on and so forth, it's kind of your best pro there. It's generally the cheapest, which makes it a little definitely makes it worthwhile to look into. And it's got some really good hybrid cloud strategies, which I won't get into because that's a whole nother discussion for a whole other day. But it's got some really cool stuff there. But unlike AWS, it does have a lot less offerings as what it can do. But it really is more geared toward enterprise customers, not your little mom and pop. I got one little database to hold, so careful there. So Google Cloud plays really nice for all of its services. Excellent support for containerized stuff. And one of the coolest things that it has over everybody is Google has their very own global fiber network. So if you have your stuff in Google servers, you can basically throw latency out the window because of their global fiber network. If you have your application on a Google server and your database on a Google Cloud server, it's like they're sitting on the same machine, no matter where they are, because they own that whole network, which makes it very, very, very nice when you're looking at it. But you pay for that. And they have limited services compared to AWS and Azure, as well as some limited support for use cases. So careful there. So some considerations for cloud or any database for that matter. Not all applies, but some stuff that you really need to consider. Maintenance. Always maintain your system. Generally for cloud, it's handled by the provider. nothing you really need to do there. They will keep your system up to date for you. But if you're doing it self-hosted, you're going to have to do it all on your own. So make sure you are handling that. Your system doesn't go dormant for months and not get security updates and other things that are important to make sure your data stays your data. If you're using a cloud solution or somebody else's solution, and you're using that, make sure you pay attention to any outage windows that are coming and maintenance alerts that could potentially bring your system down. Make sure you pay attention to all of that. It's very important that you're watching all of that, especially if you're not doing the work. So be very careful with all of that when it comes to maintenance. Number one thing is do maintenance. A lot of places I've seen, most systems that generally get compromised and out there generally just weren't up to snuff on maintenance. So it's a very good thing to make sure you're keeping up to date with all the maintenance on your machines. Very, very critical. Security, just like maintenance and updating. Security is generally well managed by the provider. They will give you tools for security, but they're only as good as the tools that you use. If they give you tools for maintaining security on your stuff, use them. Don't look at security of your database as something that's in the way. It's designed to be in the way. It's designed to make things hard, unfortunately, because if it was easy, then people could just get to your stuff. But if you're using security and they have tools, make sure you educate yourself on how to use those tools. Because if you don't use those tools properly, you might as well not use them at all. So it's good to make sure you're doing everything properly. Availability and outage. Connection failures can bring apps down very easily. Make sure that your database is available all the time. Somebody mentioned Cloudflare earlier. For those that were under a rock a while ago, Cloudflare, one of the largest providers out there of cloud hosting, had a problem with one of their network adapters, and it brought so much stuff on the internet to its knees. It was interesting how much stuff died on the internet when Cloudflare went down. I think stuff like a lot of gaming stuff like Discord. Discord was offline for a while. Parts of other gaming infrastructure. I think some video games were offline. There's a lot of stuff like some parts of Microsoft was actually offline. Some other things that you wouldn't even think of just died, were unavailable. Lots of random stuff that you would never think. Some adult-oriented things went offline, which was kind of funny. Lots of things, and it's happened with not just Cloudflare, with other providers. These major infrastructures just die, but they die in a weird way, where like something goes offline and their entire infrastructure just ceases to function. So be cognizant of that. And I mean, it doesn't happen often, but it does happen. Make sure your app can deal with the fact that you don't maintain the server and it could go offline. I mean, they kind of handle their errors a lot better, and can gracefully deal with things. But I think when Cloudflare went down the last time, it was down for a few hours. There were a lot of systems that were just unavailable for hours, or available depending on where you were, which is really weird. So be careful. Like I said, latency. Always be cognizant of where things are. Latency is a big killer. This can kill even the most well-built apps in seconds. So make sure that your latency is down to do a minimal. And when you're writing apps in your database and your app server aren't like holding hands side by side, don't do select stars on any of your data. Make sure you're actually only getting the data you need and using the data you need. Don't pull massive amounts of data, thousands of rows, hundreds of columns of junk that you're not even displaying. If you want to count rows. Don't pull a bunch of rows and then count the result. do counts, stuff like that. Be very careful with the data you're pulling, especially, I mean, if you're using ORM, and especially use lazy loading with ORM. Don't have ORM reach out and grab everything. Not lazy loading ORM objects is probably one of the biggest killers I've seen. Everybody forgets to lazy load your relationships. So when you grab a user object, it's going to grab your entire database they're connected to if you don't lazy load it. So make sure lazy is true for all that stuff. You don't want to overwhelm your app server or the network, your database with a whole bunch of stuff. And if you're paying for bandwidth and you're pulling back select stars, you kill something. And here's another fun one that I've given people a lot of times on why select star is generally bad. Let's say you built an interface a year ago. And you're displaying 4 columns. Their table had 4 columns. You have an interface to display those 4 columns, so on and so forth. Now, a year later, you've added some stuff to it, and you've added a blob of data, a big, large chunk of data to that. Let's say giant JSON blob of data for every row. So you're now storing that in there. But you never fixed the interface that you built a year ago to list out the contents. So you're just still doing select star where something and pulling back thousands of rows. But now that select star is also pulling back a giant JSON blob of data that you're not even using because somebody added a column later. So always choose what columns you need for whatever you're doing. I will do select star when I build something just to get all of it when I'm first building it. And then once I go through and I decide what columns I'm using, what I need, I then remove the star and add the actual column names in. I never use anything with select star. It's just super bad. I've actually had presentations on why select star is bad. So a lot of things. Another big one is throttling. Most people don't even realize this actually occurs, but it does. It happens way more than you ever think it does. Make sure that when you're getting your hosting for your database, that you can't be throttled, or your SLA says you can't throttle me, or you sign something, or you pay more to say don't throttle me. Because a lot of times when systems get overloaded, you will you get throttled. They will reduce your bandwidth to your data, and that's bad. So your latency that didn't exist, you now have a ton of it because they throttled you for a while, and then so killed your database, killed your system. So be careful with throttling. Make sure you're not being throttled. And if you're going to go out there and pay a ton for services, pay a ton for hosting, add all these stuff, make sure that you're actually using what you're paying for. Don't add a whole bunch of features to something and not actually use those features. If you got extra add-ons you're using, don't just keep adding stuff as long as it look cool. You're paying for it. I mean, it's cool to turn something on for a month and say, hey, I want to try this feature out, see what it does. And then after that, turn it off if you're not going to use it. Don't just leave it there. I actually had a nice conversation with Google one time because I had set up a VPS to play around with something in Google and forgot about it for 6 months. I ended up getting a nice little bill. Had a discussion with them and showed that there was no activity, nothing being done. It just sat there, and they were gracious enough to not charge me. But that doesn't always work. But how do we know which one is not being used? I would assume if you turned it on and played with it and you didn't use it anymore. But don't know. That's a good question. So where do you start? Well, I'll start at the beginning. Get all your specs together. Figure out what you need, what you want, where you want it. Decide on a provider, and then you're off. It's kind of how it goes. Basically, just do what we did in this presentation. Get your specs together. Figure out where you want it. Figure out all your stuff. And then figure out what fits. There are lots of providers out there. Figure out what fits best for you. And if best fits for you and your application, don't just get something because everybody else does that. Get what works best for what you're doing. Not a big fan of just doing that because that's how we've always done it. There are lots of options out there, so always use what works best for what you're doing. And with that, I will go through the questions and we can chat for a few. We've hit the end.
Yeah, Dave. So thank you so much for this presentation. It was awesome. If you stop sharing your pod, yeah, there you go. You should be able to see the Q&A, and there are definitely some questions in there for you.
Let's see. Dave L. asks, at what point do you recommend keeping the database server running on the same machine as the app versus moving the database to a separate server? Never. Never store your app and your database on the same machine. Ever, never, ever. Because then you're now sharing resources between two different things that are heavily resource intensive. So never do that. Always have them separate. Let's see, Sean, backups are for people without confidence in their stuff. I'm gonna disagree. Backups are crucially important. Let's see. John asked, "What if we don't think? How would you say? What if we don't think in sysadmin patterns? How would you suggest we approach deployment?" That's tough. That's all on what your app needs, honestly. What kind of infrastructure you need for your app. A lot of it, I mean, I've seen people try and wedge stuff in because it's how they've always done it, which doesn't actually meet the needs of the application you're building. So look at what you need to do to handle for your app and then go from there. Let's see. You said earlier to keep your app server close to your database. How wise is it to have your VPS and your app server use a cloud provider as your DB saw? Latency is a disadvantage. Reading this partially out loud. So a lot of questions in here. Hang on. I'm going to go back. This one has like a bunch of questions in it. Let me try and go through this one by one. So Joshua 4 says, you said earlier that it's good to keep your app server close to your database. How wise is it to have a VPS for your app server and use a cloud provider as your DB source? I generally no problem with that, but I would try and make them the same provider because then your latency is going to be drastically reduced because they're going to have infrastructure between the two versus going out on the internet. Is latency a disadvantage? Latency is always a disadvantage. So you want to keep that latency down as best you can. If you have different providers, let's say you're hosting your database in Azure, but AWS has your app, then you're going to have some latency. So you want to try and reduce that as best you can. With multiple edge locations for doing these platforms route DB requests intelligently. Generally, yes. Generally, most systems will intelligently route traffic between an app server and a database server on the same provider internally very, very intelligently. So you don't need to worry about that. Google's probably the best at that because they own the entire network. So I think I kind of covered all of the rest of those questions in one statement. Are there any advantage to using Azure by Microsoft and use other apps like Teams, Sync, API calls, technologies to use? Is there any advantages to using Azure by Microsoft to use their other apps like Teams, Sync, API calls with other technologies with use from them in our enterprise? I'm not quite sure I understand the question. I mean, Azure, if you're using the Microsoft infrastructure, then Then Azure's really good. Apparently, Greg's going to handle this one. I just let me know, Greg. I'm here.
Yeah. That's usually a bad idea. we try not to let Greg handle too much, because then we end up having to deal with bail and other situations. Yeah.
Let's see.
I think if you scroll up chat, there were a couple of questions.
I got one last question in the question pod, which I'll get to. So Annette says, can you re-explain the bit about the cost difference between horizontal scaling and vertical scaling? Sure. So horizontal scaling is adding power to an existing machine. So you're growing it, you're making a single machine bigger. You're adding floors onto a building. Vertical scaling is adding more machines to what you already have and making them work together. So you vertically scale by adding RAM. RAM is cheap. You can always add more RAM. RAM is cheap. Processors are cheaper than they used to be. So you can always add more processors, more RAM to a machine. But you hit that critical point where they can no longer be expanded. So you have to either get new hardware and made a new machine, which can be then vertically scaled. So you have that route. Or you have a smaller machine and a bunch of smaller machines to scale horizontally. So there's two different types. So adding more smaller machines is more expensive on the onset, but becomes cheaper over time because they become cheaper over time. Where adding more power to an existing server starts out cheaper and then becomes way more expensive over because of how you may run out of space in the system, so on and so forth. So those are the two different ways to do that. Let's see, what other questions did I miss in chat here? Stop scrolling down when I'm scrolling up. Why is sharing resources bad? So sharing resources. So Dave L says, why is sharing resources bad? Doesn't this go along with your storing your motorcycle in a 4-car garage? If you've got a single car garage, why not share it with 2 other motorcycles? Well, so here's why you wouldn't want to do that. First off, don't get a giant 4-car garage to store more than you need because you're basically wasting space, wasting power. Get something that fits. Because you can always look at it and say, yeah, I've got this thing. I'm going to put this other thing in it. I'm only going to use like 25% of the power. So we got 75% that's sitting there idle. I can put other things in there to use that other 75%. Well, you can and you can't. Because what you want to be able to do is you want your server to sit there around 30-ish% utilized all the time. You want it to be able to spike up to 80%. You don't ever want to have a server that spikes to 100% because now you've maxed it out and can't do any more work until whatever work is done is gone through. So you want a server to be able to spike up to about 80-ish%, but never max. And you don't want it to spike up and plateau. You want it to be able to handle things and calm back down and work and handle things and come back down. When you start sharing resources and putting multiple things into a single thing, then you run out of room to spike. So if you have something that's running and it's spiked the processor to 80%, anything that else needs to run is now only going to have 20% of the system to use. And if it needs to spike up to 80, you've now got contention, major contention against the system. And now you run out of resources and now hinder everything. So you always want to kind of purpose-built machines and let them do what they need to do effectively and not have them kill themselves. Let's see, was there anything else that I didn't get through? All right. I need to give out a gift card, don't I? I just say who wants it and see what happens. No, I'm kidding. Who wants the gift card? Everybody will take it. Of course. Let's see. I'm going to do something I'm going to ask a question, and the first person to answer it will win. Does that sound fair, Mark? If Mark is even still listening to me. Mark's not talking.
It would help if I wasn't muted. Yeah, that sounds great, Dave.
That sounds great. All right, so
Make it a tough question.
I'm going to ask a question that for those that were paying attention in the classroom, and then see who can answer it. I'm going to do this real quick. Go to another window. Let's see. Here's the fun question. See who was paying attention, because this was briefly mentioned, but was out there. And we're going to
keep in mind you're not sharing your screen anymore, Dave. If you're
I'm fully aware. I was looking at something to make sure I had the right answer.
Got it.
That's the important part. I'm like, and make sure I'm not lying, because I wanted to make sure it was actually in. Because I know what I wanted to ask. I just want to make sure it was actually in the presentation. I must make sure one more time. Wasn't it? Maybe it wasn't. Actually, it wasn't. Dang it.
Oh, that would have been funny.
Yeah. Let's see. So I want to grab something that was in the presentation. Oh, it was. Okay. It was. Okay, here's the question. Everybody ready?
Right.
What is the name of the NoSQL database for GCP that was in the presentation?
Robert. Good one, Robert.
Everybody's close, but nobody's actually gotten it yet.
Remember, it's the one that was in the presentation, folks.
Annette got it. It's actually Firestore. A lot of people said Firestorm.
And Firebase.
And Firebase. It is actually Firestore. GCP Firestore is the NoSQL database that GCP supports. So congratulations on that. See, it helps pay attention. Or Google faster than everybody else.
Ha! All right, Annette, please send me an email at takata@adobe.com so that I have your name and email to get your voucher over to you.
There are actually two, but there was one that I mentioned in the presentation. They actually do a bunch, but they're all specific to their stuff.
Very, very cool. Awesome.
Anybody have any other questions? Because I think we're really, really close to running out of time.
Well, we always have time for you, Dave. I mean,
no, you don't. You lie to me.
We never run out of time. You are the last speaker of the day, also. So
sweet. Who's excited for CF Summit in person? And wait till you hear about the presentation I'm going to do. You guys are going to be jazzed. It's going to be amazing.
It really is amazing, guys. Yeah, that no one has ever done a presentation like Dave is doing in the history of CF Summit.
Ever. No, I have a pet called Onyx. Is a fully black dog named Onyx.
John Farrar asks, "What does Mark do when he is off mic?" I message support teams on Slack to tell them to fix things. Honestly, John, that's the incredibly fun and naughty thing that I do when I'm off mic. I make loud typing noises on my mechanical keyboard.
Yep. Dan, I handed off all the CF Mobile Talks to you. They're all your job now. But yeah, I'm looking forward to seeing everybody at CF Summit. I'm excited for that to do. Oh man, that I've never been so excited about a presentation ever.
That's going to be so good.
Oh man, it's going to be nuts.
Yeah, we were. So Dave, your presentation is changing some of the ways that we're doing other presentations. We are actually asking other speakers to take some of the concepts and like not your actual concept, but some of the other stuff, and actually like incorporating that into stuff even outside of CF Summit. So yeah, you're making waves.
Nice.
Making waves.
It's going to be amazing.
Making memes and causing scenes.
Game of Thrones trailer's out. New one, nice. I'm excited.
Yeah, Greg, can't tell you what the concept is quite yet. We will be announcing that fairly soon. So yeah,
getting together with all my friends.
It's going to be exciting.
All right, we got
Perfect.
no more questions. Gonna wrap this puppy
Awesome.
up. This recording will be available at some point, I think, right?
Yes. It will be up. We are recording this. It's been taken about a day or two to get things up onto YouTube. So it just kind of depends how long YouTube takes to encode things, which is always fun to deal with. So I am going to punch us over to the outro. Folks, please, let's vote and tell Dave how he did today. Definitely, please vote if you enjoyed his poll. Please vote if you didn't. I mean, we just want the votes because these are incredibly important for our speakers. They help them hone their craft and let them know how they did today. So thank you, Dave, so much. That was an awesome talk.
And if your response isn't one of the top 2 items, DM me on Twitter and let me know why.
Yeah, there you go. Yeah, don't do it in person because I don't know, you might end up defenestrated. But
I got a couple skills.
Skills to pay the bills. Actually, I think your skills cost you money. I would imagine all that travel and.
I have had 3 surgeries due to Taekwondo.
Yeah, expensive.
Yes.
Expensive stuff. Oh my goodness. And for everyone, as I mentioned, today is done. Dave finished this stuff strong, but tomorrow morning, join us early in the morning for Brian Class talking about I didn't know S3 could do that. So I'm actually really curious about how all that will work. I'm going to leave this poll up for a bit. We will be closing the sessions down a little bit early today to try and get some more things done, reset a few things, kick some hamsters, do all the things that we need to do for tomorrow's talks. So you will hear me make that announcement in about an hour or 2. In the meantime, thanks again, and we will see you tomorrow.
Thanks, everybody.